Hello everyone. My name is Vivek. I am a software developer. I make videos about containers, Kubernetes, Go as a programming language, distributed systems, and sometimes about software engineering in general. So, if you have been liking the kinds of videos that I make, you should consider subscribing to the channel and you should follow me on Twitter as well. In this particular video, we are going to look into how we can provision a Kubernetes cluster version 1.22. So we know that this particular Kubernetes version was released recently, and there are a lot of group and versions that are going to be removed in this particular Kubernetes version. So they are not actually going to be deprecated, but some of them are actually going to be removed from the API server. So a lot of cloud providers are not actually supporting Kubernetes or do not have a way to create Kubernetes cluster version 1.22. So that is the reason I thought I should make a video on how we can create a Kubernetes cluster version 1.22 using three Ubuntu instances. So let's just go ahead and as we know, we already have, or I already have created a video on the very same topic where I set up a Kubernetes cluster, three node Kubernetes cluster on three Ubuntu machines, and I already have this repo where I have pushed all the changes, all the steps that you can follow. Now, to create a Kubernetes cluster, three node Kubernetes cluster with version 1.22, we are going to follow almost the exact same steps, but there are some minor changes. So I'm also going to tell you that, and I would obviously push those changes in another branch in the same repo. So first of all, we will have to create three Ubuntu instances. So let's just go ahead and try to create them. So I am on DigitalOcean, and in case of DigitalOcean, we can create droplets. So I want to use Ubuntu 20.04 basic plan, and I don't want any storage as of now, and I want them to be in Bangalore. Now, if we talk about authentication, usually we would want to use SSH keys, but for this particular video, I'm just going to use password authentication. But as I said, in most of the scenarios, you are going to use SSH keys, or you should use SSH keys. So let's say this is the password that I have specified, and I want to create three instances. So this is one, let's make it three, and these are the names that we are going to have for these three instances. Now let's tag them. It's totally fine if we don't tag them, but just to make them distinct from other droplets, we can also tag them. And I think we are good. Let's click on create droplet, and we should get three droplets or three instances in a second. Now, as soon as these instances are created, we will have to SSH into these instances to actually install the things, or actually install Kubernetes cluster. Now, the things that we are going to install in these instances, I talked about those components, I talked about those services in detail in the first video. So I will link that video in description or somewhere, so that you can check that out as well. So for example, if we look at this particular document, we are going to install a lot of things on those instances. And to get to know why do we want to install those instances, uh, I would recommend checking that video out, and we are very briefly going to discuss about them as we go on with this video. So let's SSH into these instances. We got the IP addresses, and we are going to make 01 the leader node, and other nodes are going to be follower nodes. So copy the IP address and SSH root and IP address, and we know the password. So And here we go, we are in that Ubuntu instance that we are going to make a leader node. Let's SSH into the other nodes as well. So SSH root add, and similarly we are going to SSH into a third one as well. Alright, so now that we are into those instances, let's try to follow this cluster steps setup readme that we have. So obviously we will have to update the packages. So let's just copy this command over on all the machines, and if we see here, we have to do this on all the nodes. So this just updates the dependencies and their versions. So we are going to run that on every instance that we have. While this is being done, the other thing, let's talk about the things that we are going to install. So for example, we are going to install kubelet, kubeadium, and kubectl. So we know kubelet is a service that runs on all the nodes, I would say, of the Kubernetes cluster, and this actually talks to the container runtime that is running on that machine to actually create containers, etc. So that is the responsibility of kubelet, and kubeadium is the project that we are going to use to spin up or to create the Kubernetes cluster. And we obviously know what kubectl is. Kubectl is a client to access your Kubernetes cluster. So these are all the things that we are going to install. And yeah, we will also need a container engine, and we are going to use Docker, but I think you are free to use any of the container engines available out there. Now that we have done that, let's just go ahead and install the other required things. So curl and other things, and these packages that we are going to install, all these packages are we will have to specify which particular repo these packages are going to be installed from. So that is the reason we will have to add the Kubernetes repo as well. So yeah, we have verified the key. And now, so for example, if you install anything, if you are aware about Helm, if we try to relate it with Helm, when we try to install a release, we specify or we add a Helm repo. I think that is what is being done here. So we will have to specify where are those dependencies available, and as soon as we have specified these, let's obviously, after adding the repo, we will have to update the dependencies once again. And if you notice, I'm running these commands on all those three instances. And if once we have done that, all we have to do is we have to install, or we have to install kubelet, kubeadium, and kubectl. So let's just go ahead and try to do that. And once we have kubelet, kubeadium, and kubectl, we will have to install container engine, and in our case we are going to use Docker. So this might take some time, and yeah, once we have installed all these dependencies, we can initialize a specific node as leader node, and this is the command, kubeadium command, that can be used to initialize that. So I think we are through that. Now let's just go ahead and run this particular command, or we will have to install Docker as well. optionally we can run this command, this as this comment suggests. This makes sure that these version of these packages is not updated automatically. And here we go. So we are done with the setup on all the instances. Now what we have to do is we have to on leader node we have to run this particular command to initialize that node as a leader node. So let's just go ahead and try to do that. So, and we can obviously figure out IP address by following this uh, page, and I think we are good to run this particular command. So as soon as I run this particular command, kubeadm project is going to initialize a Kubernetes leader node on this particular instance, that is 0 1. So let's go ahead and try to do that. Okay, there seems to be a problem. So it looks like we have a typo here. There should be a space before hyphen hyphen pod network CIDR, and this is actually as the name suggests, this is the range in which IP addresses for the pods is going to be assigned or created. So yeah, you can read about this particular flag more if you follow Kubernetes documentation. So as you can see here, there are some checks that are being performed, and kubeadm actually starts kubelet, and then kubelet tries to initialize the control plane by looking at the pod manifests from static pod path. Static pod path usually in case of Kubernetes is etc Kubernetes manifests. And if you see here, now kubelet is actually trying to create these three pods, and if you see here, it is waiting for the kubelet to boot up the control plane as static pod. Yeah, so this is the static pod path, and kubelet is trying to create those control plane components by looking at the pod manifests at this particular location. So yeah, it looks like kubelet is not running. So let's wait for some time. Let's wait for this particular command to fail, and then we can talk about how are we going to resolve this problem. Yeah, so as we see here, this command has failed, and we are clearly able to see that kubelet is not actually running successfully. So if you see here, it simply says that waiting for kubelet to boot up, and it also says that kubelet isn't running or healthy. So here are some of the details about that failure and some of the suggestions that can be used to actually recover from that problem. So first of all, what we should try to do is we should undo whatever we have done until now. So kubeadm init did some things, but that failed. So let's revert that, and then we would run that again. So kubeadm reset, and if you see here, it simply says that the changes that were done by kubeadm init or kubeadm join will be reverted, and that is what we want to do. So we have reverted that. Now let's because the error was clearly saying that there is something wrong with kubelet, let's go ahead and try to look into the status of kubelet service. So kubelet is actually maintained by is running as a service on this machine, on this instance, and it is being managed by systemd. So we can use systemctl to check the status or manage that service. So status and name of the service, so kubelet.service. And if you see here, it simply says that code exited, and the service is not actually running. The value for active is inactive. So to actually figure out what exactly the problem is, let's go ahead and try to look into the logs of this particular service. So systemctl, or we will have to use journalctl to check the logs. So name of the service is kubelet, and we want to check last, let's say 50 lines, and we want to follow the logs. So yeah, here we go. If we see, it is clearly saying that failed to run kubelet because misconfiguration. Kubelet cgroup driver is different from Docker cgroup driver. So we know what kubelet is, we know what Docker is. Now the problem is, both of these components should use same cgroup driver, and that cgroup driver can either be cgroup fs or it can be systemd. Now it's highly recommended that we should use systemd. So now the change that we have to make is, since kubelet is already using systemd as cgroup driver, we will have to make sure that Docker is also using systemd as cgroup driver instead of cgroup fs. Now to make that change, we know that whenever we run a particular program, an application, there are some configurations that can be provided to that application, and exactly same thing happens with Docker as well. So Docker is running as a service on this particular machine, so we will have to start that service by specifying custom or different cgroup driver for Docker. So let's just go ahead and try to do that. So first of all, we will have to figure out which particular service file or unit file Docker is running from, and we can do that using this particular command. So for example, systemctl, if we check status of Docker, Docker is running, and this is the unit file that is being used to run Docker on this machine. So let's just go ahead and try to look into that system file. So lib systemd system, and then here we should have something called Docker service, and this is the unit file, this is the main configuration file, we can say, for the Docker service. So if you see here, this is the command that actually runs user bin dockerd with this particular flag to run Docker on this particular machine. So we will have to change, so or in other very simple words, we can say that this is the binary that is running Docker, or this is very naively we can say that this is the Docker, and with this particular flag it is being run. So all we have to do is we have to specify the cgroup driver to be systemd for this particular binary, because now, as of now, it is being run as cgroup driver to be cgroup fs. Now to do that, like we have this particular flag here, we can have another flag, and that is exec option. So let me just copy the exec opt, and then we have to specify that we want to use systemd as cgroup driver. So this is how we can do that. So we want to run containerd with this particular option, and we want to use cgroup driver to be systemd instead of cgroup fs. So let's save this, and obviously if we have made changes in the unit file, we will have to reload that file. So systemctl daemon reload, and once we have reloaded the unit file, let's restart Docker so that it runs using systemd cgroup driver. So systemctl restart, and then Docker service. Okay, here we go. So Docker is running, and now let's go ahead and try to run kube-system init command once again. So and let's see, things should work this time. Yeah, so if you see, we are at the same step, waiting for the kubelet to boot up the control plane as static pods, and here we go. So this time things worked as expected, and we see that now we can run this particular command to join follower nodes to this particular leader node. So let's do this on the other instances as well. But before doing that, we know that we are running Docker on these machines as well, so we are going to face the same problem. So let's just go ahead and try to change the cgroup driver in these two instances. So we will have to, let's say, check systemctl status docker.service, and Docker is running, but we will have to make it run using systemd cgroup driver. So cd, we know that the unit file is present here, so systemd system and then docker.service. Let me copy over the flag, and it is going to be execop, the exact same thing that we did on the leader node. So, and systemctl daemon reload, and then restart the service. So systemctl restart docker.service. Okay, and we have to do the exact same thing on the other instance as well. So lib systemd system exec-opt, and we want to change the cgroup driver to be systemd, and systemctl daemon reload and systemctl restart docker.service. And here we go. Let's make sure that we have Docker running on all the machines. Here we go. Okay, so now all we have to do is we have to run this kube-system join command to make these nodes join the leader node. And here you see we are able to see that these nodes are joining the leader node. Now if we go ahead and run kubectl get pods, we are not able to get that because we will have to specify kube config file as well, and there is a command to specify kube config file. So we have specified kube config file so that kubectl would be able to figure out where exactly Kubernetes API server is running and the credentials it has to use to authenticate itself against API server. So kubectl get ns, and we can clearly say that all these namespace are created 4 minutes back, and if we get pods from kube system namespace, we see that all the pods are running, but core DNS pods are not running. And the reason is we have not installed a very important component for the Kubernetes cluster, that is a network plugin. I am going to make some videos about networking in Kubernetes, where we will be discussing about network plugins in very much more detail. But for now, we can say that network plugins are necessary, uh, as the name suggests, to make pods communicate with each other and etc. So let's just go ahead and try to install a network plugin. We have a lot of options to choose from, but we are going to install Flannel this time. So Flannel, Calico are some of the options. So we are just going to install it. If you see here, uh, we applied this particular manifest, and these are all the things that were created. Now if we get the pods again from kube-system namespace, you see here now these two pods are running, and we are actually ready to use this Kubernetes cluster. So I'm exiting from the other worker instances, because we don't actually need them. So if I run kubectl get nodes, as you see here, we are successfully running three nodes. One is obviously leader node, another two are the follower or worker nodes. And if we run kubectl version, we can see that we are running Kubernetes version 1.22. So very quickly, to make sure we are running everything fine, everything is working as expected, let's just go ahead and try to run an nginx instance here, and we would access that from outside of the cluster. So I'm going to run kubectl create a deployment nginx, and image is going to be nginx, and let's expose that deployment. So kubectl expose deployment nginx, port is going to be 80, and type is going to be node port. We want to create node port kind of service. If you don't know about type of the services, I already have a video about this, so maybe you can check that out. If we try to get everything, we should see nginx pod and nginx service. Now let's just go ahead and try to access this nginx pod. We can use the node's IP address. So if you are using node port kind of service, we can access that service using any node IP of the cluster. So kubectl get nodes, and we want to figure out IP address as well. So let's use this IP address. So let's say we want to use this IP address. So IP address and then the port. So the port, if we look at the service, is 32425. And if everything is working as expected, we should be able to see nginx running there. So yeah, I think this is what I wanted to talk about in this particular video. If you think if you liked this video, you should subscribe to the channel. If you think this is going to be useful to your colleagues, your classmates, maybe share it with them. I'm obviously going to update this readme that we have here, and I would create another branch in the same repo with the newer steps that we followed. Thank you so much for watching, and I will see you in the next one.